In this video, we would like to derive an equation for the work done in the case of a adiabatic process. First, let me tell you what do you mean by adiabatic process. It is the process in which we keep the heat energy of the system constant. We don't allow any heat energy either to come in or go out. It is perfectly insulated. Therefore, the heat energy of the system always remains constant. That means change in the heat energy of the system equal to 0. And we have derived a relation between P and V in adiabatic process as PV power gamma equal to constant, where gamma is the ratio of specific heat Cp by Cv. In this process, now we want to derive an equation for the work done. We know dW can be written like PdV. To get the total work done, integral of dW equal to integral of PdV, where volume is varying from V1 to V2. We are trying to integrate with respect to V. Inside you are having a P which is not a constant. So that P shall be expressed in terms of V. So what we have to say, as in adiabatic process, PV power gamma equal to a constant. Of course, that can be written as P1 V1 power gamma or P2 V2 power gamma as and when it is required. That implies in the place of P, we can write constant by V power gamma or constant into V power minus gamma. Let us substitute this value of this P in this equation here. That implies, tell me what happens. Integral of differentiation of work done is work done. Integral of, in the place of this P, I can write K V power minus gamma, and the remaining one is dV. Now we can use a formula of integration as what? Integral of x power n dx equal to x power n plus 1 by n plus 1. Here n is nothing but equal to gamma, right? So what happens if you simplify the equation? Yes, let's do that. From this equation further, work done W equal to integral of A V power minus gamma dV. So yeah, I can write K outside the integration using this formula, integral of x power n dx, V power minus gamma plus 1 by minus gamma plus 1, where the volume is varying from V1 to V2. So V1 is the lower limit and V2 is the upper limit. It implies work done equal to K of minus gamma plus 1, of course. V power of 1 minus gamma by 1 minus gamma, where limits are from V1 to V2. So I can equate that further as K by 1 minus gamma. This V, first we have to apply upper limit minus lower limit as per the rules of integration. That is V2 power of 1 minus gamma minus V1 power of 1 minus gamma. I can take that K also outside. So the work done is equal to 1 by 1 minus gamma K V2 power of 1 minus gamma minus K V1 power of 1 minus gamma. But what is the value of this K? This is the value, PV power gamma. So in the place of that K, I can write PV power gamma or P1 V1 power gamma or P2 V2 power gamma. So in the place of this K, as the neighbor is V2 power of 1 minus gamma, I will write K as P2 V2 power gamma. Next, in the place of this K, as the neighbor is V1 power of gamma minus 1, I will write P1 V1 power gamma, so that equation will be further simplified easily, right? Let's do that. That implies work done in adiabatic processes 1 by 1 minus gamma into, in the place of this K, to simplify, I will write this one, P2 V2 power gamma. Remaining is V2 power of 1 minus gamma. By writing like this, I can simplify this. That's why I'm trying to simplify the equation. Next, in the place of K, as the neighbor is V1, I will write the value of the K in terms of V1 as P1 V1 power gamma, and the neighboring term is V1 power of gamma minus 1. So, if you try to simplify that equation further, work done in adiabatic process is W equal to 1 by 1 minus gamma of V2 power of gamma, V2 power of 1 minus gamma. As the base is same, the powers can be added. So that is B2, V2 power of gamma plus 1 minus gamma. Similarly, minus P1. Here also V1 power of gamma plus, this is K V1 power of actually 1 minus gamma. 1 minus gamma only. I shall correct it, right? V1 power of gamma, right? Plus 1 minus gamma. So what happens? These gammas will be cancelled. That implies work done is equal to 1 by 1 minus gamma P2 V2 power minus 1 minus P1 V1 power minus 1. That implies work done equal to 1 by 1 minus gamma of P2 V2 minus P1 V1 is the equation for work done. But as gamma is always greater than 1, I will get a minus in the denominator. To avoid that, let's multiply with a minus. Then the terms will be swapped automatically. Right? That's the equation for work done in adiabatic process. Of course, I can write it in another format also. As what? As PV equal to nRT. I can write work done as 1 by gamma minus 1. In the place of P1 V1, I can write nR temperature T1. Minus in the place of P2 V2, I can write nR T2. So work done in adiabatic process can be expressed in terms of temperature as, get this nR out, nR by gamma minus 1 of T1 minus T2. So you can express in this format also. So there are two ways of expressing adiabatic process. Either this way, work done, or this way, work done. We will use the first one. When the data is given in terms of pressures and volumes. We'll use the second one when the data is given in terms of temperatures. That's how we can derive an equation for the work done in adiabatic process. That's it. Thank you for watching.